So we know for all the tests we have to find the test statistics. For the Z test we find the value of Z or Z, and for the T test we have to find the value of T or T statistics, and this is the formula. If you see the formula, so this is the formula for the T test. X bar minus mu. Mu is the population mean, if you that is known, and S is the standard deviation of the population, and N is the sample size. So this is the X bar is the mean of the sample, and S is the standard. I told you N is the number of sample, and S divided by root over N is known as the standard error of the sample. Okay, S is the standard deviation, but when you divide by root over N, that is called standard error of the sample. And for true distribution, one more parameter that I told, when the sample size depend on the sample size, so we need to add one more parameter that is called degree of freedom. Normally this degree of freedom is calculated by n minus 1. From the sample you have to minus 1. That is the degree of freedom is simply the number of samples that have freedom to change without affecting the sample mean. In the from here, only population we know the mean, so this is for we are doing the minus 1. This is the degree of freedom for the samples, because there is only one parameter, that is mu, it is known, so we have to give minus 1. Just remember, for the T distribution, when the sample size is n, and the degree of freedom will be n minus 1, and there is a very important criteria that differ the T distribution or T test from the Z test. From this test n is fixed, but T test, the number of degree of freedom changes as the sample size changes. Okay, now we'll do some example. So this is example for one sample T test. Okay, if you read down the example, that is the Duracell, a battery manufacturer company, and the CEO of this company claimed that the average lasting or longevity of the battery is 300 hours under normal use. So somebody want to check, a researcher randomly selected 20 batteries from the production line and tested the battery, and he got the lifespan of the battery is 270 hours with a standard deviation of 50 hours. See, in the population, we know the only sample mean life, but we don't know the variance. So, and standard deviation also. So what do we do? Do the researcher have the evidence suggests that the claim of the average lifespan of 300 hours is true? That is, we have to, from the sample, we have to verify the claim of the CEO who claimed their lifespan of their battery is 300 hours. So how we can formulate test hypothesis and alternative hypothesis? Let us see. So first of all, we know first step of the test statistics or hypothesis, we have to formulate null hypothesis and alternative hypothesis. And for the two-tailed test, we have to agree with the claim. That is, the claim of the CEO of the company is true. That is mu equal to 300 hours. That is the mean life span of the battery is 300 hours is true. And alternative hypothesis, we have to degree. That is, his claim is not true. That is, we have to prove by the sample. So for that second step of the hypothesis, we have to fix the level of significance. As I told, if it is not given, the standard value of level of significance is 0.05. That is 5%. We have to keep it. That is also it is denoted by alpha also. Okay. And third step, we have to calculate the test statistics. That is, here we have to do the T test, because sample size, see, if you see the question, sample size less than 30, that's 20 batteries, and population variance is unknown. We have it is calculated from the sample. So we have to use the T test, not the Z test. Okay, almost the same formula. So we have the formula for the T test, x bar minus mu divided by S root over n, and S bar is the sample mean, that is given 200. That is given already. So now put all the value. That is the mean from the sample, you got 270. Population mean is given 300, and the sample standard deviation also calculated given 50, and sample size is 20 battery. All are given in the question paper. Now, if after putting all the value in the formula, you will get the value of T 2.68. It is a minus 2.68. As we know, when the hypothesis two-tailed test, we have to take the absolute value. So absolute value will be 2.68. Oh, so this is the, so in this way we can calculate the T statistics, and always remind that we can use the T test when the sample size usually less than 30, and most important one, population variance is unknown. It is calculated from the sample. Okay. Now then third step, we have to find the critical region. Okay. For the critical region, I told you we have to t-test, you have to consider degrees of freedom. Here degrees of freedom will be n-1, which is 19. So for 90 degrees of freedom at 5% level is significant. For two tail test, the tabulated value of t is 2.093. Let us know how we can calculate tabulated value. And we know critical region, that is rejection region, will be greater than the tabulated value. Let us see how we can calculate the t statistic tabulated value. Okay. So at the end of the slide, I give you that t table. If you go to the t table, okay, let us see at the end of the slide, I put it the t distribution table. So if you go there, at the top of the line, one tail test and two tail test. So our test is the two tail test, and here degrees of freedom. See at the first row, first column is the degrees of freedom. Okay, first column is the degrees of freedom, and all the column are the critical. That is the all this will be the level of significance. For two tail, our level of significance is we have to divide by two. I told you for level of significance, when the test is 2, we have level of significance will be this like this, and here it is already divided, so it will be 0.5. So 0.05. So and our degrees of freedom is 19. So if you go there for the 19 degrees of freedom, so 19 here, go there in the row 19, and our is 0.05. So here we don't need to divide by 2 because for two tail it is separately given. Okay, they are already divided. So for the two tail test, 90 degrees of freedom, value of tabulated value of t 2.093. See, you can from here. So okay, this is the t table that is we got. So critical region will be greater than 0.093. Now step 5, we have to make the decision. So our calculated value of t 2.68, positive value, which is greater than 2.093, that is false in the critical region. When the calculated value falls in the critical region, we reject the null hypothesis, accept the alternate hypothesis. I told you, when the calculated value falls in the critical region, that is greater than the tabulated value, we reject the null hypothesis. That is and accept the alternate hypothesis. That is, we reject the claim of the CEO, that is the life span of the battery is 300 hours. It is false. So his claim of CO is not true based on the sample with the t-test, and finally we make the conclusion that the claim of the CO is not true.